Well, dear friends, welcome to this video and listen me very carefully. Today, in this video, I will be telling you the concept of electromagnetic wave. Till now, in first video, I told you that what is wave. Wave is simply, I told you, variation of some physical quantity periodically with time or distance both. If somewhere some physical quantity is changing with time and distance periodically, then it means wave. In general language, we say when there is variation of something, then wave. Like I told you, corona wave, first wave, second wave. So what was that? Number of corona patients were increasing and then decreasing and then again that increased. So that was wave in that sense. Now I told you displacement current and there we got varying electric field, produce magnetic field, and from Faraday law we know varying magnetic field produce electric field. So I start here like this. From Maxwell's equations क्या इंटीग्रेशन E dot dl equal to minus d phi b over dt. This is in fact third equation I gave in one video. And integration b dot dl equal to mu 0 into epsilon 0 d phi e over dt. This is third and fourth equation of Maxwell. From Maxwell equations, here we can say that time varying magnetic field we can say time varying magnetic field produces electric field, and time varying electric field produces magnetic field. Time varying electric field producing time varying electric field magnetic field, time varying magnetic produce electric field, and hence the variation in either produces the other field. Hence variation in either field produces the other field. यानी इफ यू चेंज, अगर आपने मैग्नेटिक फील्ड चेंज किया तो इलेक्ट्रिक पैदा हो गया. इफ इलेक्ट्रिक फील्ड पैदा किया तो इफ वेरिंग इलेक्ट्रिक इफ यू चेंज मैग्नेटिक फील्ड, हिंदी बोलने में दिक्कत है, तो अगर हमने मैग्नेटिक फील्ड को वेरी किया तो इलेक्ट्रिक पैदा होगा, इलेक्ट्रिक फील्ड वेरी किया तो मैग्नेटिक फील्ड पैदा होगा. यानी कि वेरिएशन ऑफ वन इज इन एनी वन, वेरिएशन इन एनी वन प्रोड्यूस द अदर फील्ड. And using this fact, Maxwell from these equations Maxwell worked out that time varying, that oscillating is varying with time or distance. Oscillating electric field E and magnetic field B Maxwell worked out that oscillating or varying electric field E and magnetic field B produces a kind of wave in this wave electric field E time varying लिख चुके हम, कोई बात नहीं. In this wave electric field E and magnetic field B are perpendicular to each other and also perpendicular to the direction of propagation. These conclusions were based on his theory only. Practically he told nothing. By this assumption there is this displacement current in the region between the parallel plate capacitor. That displacement current is numerically equal to varying electric field, and from Faraday law, that is second equation, first equation, varying magnetic field produces electric field. And various of, I am stressing again, various of any physical quantity is a kind of wave. And he called this wave as, he called this wave, he called this wave, these waves as electromagnetic wave. Maxwell predicted theoretically that whenever there is varying electric field, there will exist varying magnetic field, varying magnetic field, there exists. And these varying or oscillating electric field, oscillate means vary karna with time. By in simple pendulum oscillate, so that is changing its position. That's why we say pendulum is oscillating. Pendulum oscillate, as a electric magnetic field here, changing periodically with time and distance both. And we call them as oscillating electric field and magnetic field. So consists of electromagnetic wave. Mathematically, you have learned in class 11 equation of plane progressive wave. A wave which travel in n direction. So you have written there as y equal to a sine omega t minus kx, है ना. We have learned, or you can write this as also a is equal to sine 2 pi t upon t minus x upon lambda, और ऐसे लिखते हैं a sine 2 pi x upon lambda minus t upon t, the same thing. So mathematically Maxwell proved that electric field are there and the electric field and magnetic field of EM waves traveling in positive x direction. Now the electric magnetic field at one place vary with time, and at a given time this will vary from place to place, है ना. तो इसलिए हम क्या लिखते हैं, इलेक्ट्रिक फील्ड मैग्नेटिक फील्ड ऑफ EM वेव ट्रैवलिंग डायरेक्शन कैन बी रिटन एज वेक्टर E इक्वल टू E0 sin omega t minus kx j cap, I write j cap, and B equal to B0 sin omega t minus kx k cap. J cap, I cap, you know, are unit vector along x axis and z axis. This equation where I write here omega to 2 pi upon capital T and k equal to 2 pi upon lambda. Omega called angular frequency, k called wave number. If I divide it here or here from omega upon k, I get lambda by t, yani equal to c. This is also important note. Omega upon k equal to c. You see the speed of wave, electromagnetic wave. Electromagnetic wave के लिए है. These equations 1 or 2 can be written in different form also. The wave traveling in positive x direction, minus sign here, it becomes plus, it means traveling in negative x direction. So equation 1 and 2 can also be written. These equations 1 and 2 can also be written as vector E equal to E0 sin kx minus omega t, still traveling in positive x direction, or here j cap, or E0 sin as k equal to 2 pi upon lambda omega t, 2 pi upon 2 pi t upon t minus x upon lambda, or vice versa. Similarly, B vector can also be written as B equal to B0 sin kx minus omega t k cap, or equal to B0 sin 2 pi bracket x upon lambda minus t upon t. इसको ऐसे लिखो ब्रैकेट है ना, k कैप. तो व्हाट डू यू कंक्लूड फ्रॉम दिस? हमने जैसे लिखा यहाँ पर कि भाई E इक्वल टू E0 साइन 2 पाई ब्रैकेट t अपॉन t माइनस x अपॉन लैम्डा j कैप. तो j कैप तो इंडिकेट करता है कि इलेक्ट्रिक y-axis है. But what is the meaning of this and this? Here t time period, lambda wavelength, what is x? Position, distance from origin. यानी कि इलेक्ट्रिक फील्ड ऑफ इलेक्ट्रोमैग्नेटिक वेव एंड मैग्नेटिक फील्ड ऑफ इलेक्ट्रोमैग्नेटिक वेव are periodic function of time t and distance x. I hope you are getting my point. Electric field, magnetic field of electromagnetic wave are changing periodically with time as well as distance. So we can represent them graphically. In one video I represented wave graphically. Here, one thing more here, direction of, you will not get anywhere. Direction of E cross B, cross product of electrical and magnetic field. By E the value of electric field at time t and distance x from origin. B the value of magnetic field at time t and distance x from origin. Direction of E cross B is the direction of propagation. मैंने यहाँ कहा ना आपको, यहीं से आप ढूंढ कर सकते हैं. E क्रॉस B अगर बने तो भाई न्यूमेरिकल हो, J क्रॉस K, and you know J cross K is I cap. One year this was the question in NEET exam. Different electric field were given. Wave was shown to be a pair of electromagnetic field were given. Okay, E this one. So and wave propagation was along x-axis, positive x-axis. So you are asked to select the electric magnetic field to represent that wave. तो जिनका क्रॉस प्रोडक्ट अलोंग एक्स एक्सिस आएगा वो इलेक्ट्रिक मैग्नेटिक फील्ड उस वेव को रिप्रेजेंट करेंगे. जिन इलेक्ट्रिक फील्ड और मैग्नेटिक फील्ड का क्रॉस प्रोडक्ट डायरेक्शन अलोंग एक्स एक्सिस आएगी, इनके अलोंग आई कैप आएगी, that those electric magnetic field will be representing that wave which is traveling in positive x direction. ये यहीं से आता है निकल के, कहीं से नहीं आया. Now graphically how to represent, ये तो मैथमेटिकली होगा. ये बहुत इंपॉर्टेंट बात है जिसको हम लोग इजी लेते हैं. तो how to represent them? Suppose wave is going in the x direction. Wave going in x direction, तो जो ग्राफिकल रिप्रेजेंटेशन ऑफ इलेक्ट्रोमैग्नेटिक वेव ट्रैवलिंग इन पॉजिटिव एक्स डायरेक्शन. एक साल जेड डायरेक्शन में आ गए पेपर में, बच्चे बिछड़ गए. देखो अगर हमने दिखाना हमारे लिए आसान है इधर हाथ चलाना. अगर आपका एक्स एक्सिस आ तो एक्स एक्सिस यहाँ ले लो, जेड का तो जेड दे लो, यहाँ पे एक्स वाई जेड ऐसा आ जाएगा. अभी हमारा ये एक्स एक्सिस है, ये वाई एक्सिस है, ये जेड एक्सिस है. तो अभी हमने लिखा था वेक्टर ई क्रॉस बी आई कैप होना चाहिए. तो अगर मेरा ई इधर है तो बी विल बी अलोंग एक्स एक्सिस, जो जेड एक्सिस. वेक्टर ई इक्वल टू ई जीरो साइन ओमेगा टी माइनस के एक्स. टी इक्वल टू जीरो पर हमने लिया एक्स इक्वल टू जीरो, तो ई बराबर जीरो. Here we are representing the wave at any time having electric field along x-axis at different points. So here it is zero. Suppose it is this much here. Length of arrow gives the magnitude and direction is represented by arrow. The length of arrow represent it is 0. Then negative x direction, y direction, sorry, and then 0, and then this. So this represents the variation of electric field. This is one cycle. This is one t here. हमने जानबूझ के लिया आगे के लिए भी, तो ये 1.5 टाइम का होगा. ये रिप्रेजेंट ऑफ इलेक्ट्रिक फील्ड. मैग्नेटिक लॉन्ग जेड एक्सिस है, सेम वैल्यू, एरो शुड हैव सेम लेंथ, क्योंकि मैग्नीट्यूड when electric will have amplitude value, so electric will also have magnitude value. You can adjust the length of arrows, but it is now this way. I mean, and here 0, and then they like this. Now if we join the arrowheads, we get the wave like this. So this is the graphical representation of electromagnetic wave traveling in positive x direction. If you are asked in positive z direction, तो आप z direction इधर ले सकते हैं, इधर x, इधर y, इधर z. But remember कि E cross B should be, तो you know J cross K I होता है, J cross K क्या होता है? नहीं सॉरी, हाँ I cross J equal to K. तो आपको इलेक्ट्रिक फील्ड कहाँ लगाना है? इधर मैग्नेट इधर, एंड दिस जेड डायरेक्शन. तो मैंने देखा बच्चे जेड डायरेक्शन यहाँ बना रहे, तो उन पर वो हाथ चल नहीं रहा. हैव यू गॉट माय पॉइंट? तो दिस वाज ए लिटिल इंट्रोडक्शन ऑफ EM wave. अदर थिंग्स विल बी टोल्ड इन नेक्स्ट वीडियो, बट आई एम स्ट्रेसिंग अगेन बेटा, बच्चों, डियर लर्नर, wave does not travel, है ना, like this. Wave does not travel like this. It travels straight. This is this. What is this? This is the variation in the value of electric field at different distance. ये x distance है यहाँ पर, कि मान लो 1 मीटर, 2 मीटर, 3 मीटर, 4 मीटर, 5 मीटर का वैल्यू होगी. तो this is simply this thing, है ना. One my friend, colleague, one day he was very serious and asked me, sir, physics teacher have not clear idea. I said, what sir, what happened to you? कि sometimes they call, है ना, light on straight path, sometimes they travel along wave nature has, sometimes they say photon particle. वो different photon also travel along straight path. कोई भी wave है, whatsoever is a wave, it is propagating in straight line, not like this. Please, if anyone argue, then explain him this graph. This graph is telling values of electric field at different time, so at different distance at given time. This is the graph representing the value of electric fields at different place at any time t. Suppose at 0 time, at 0. So it will be E0 sin minus kx. I hope you have got my point. I am stressing. People don't believe. I got a feedback that Balaram sir does not know what is wave. है ना? चूँकि जिनको हम ये बताएं, जिसने ऐसे याद किया हुआ है, वो नहीं याद समझेगा इस बात को. But it is very clear here. Thank you.